I have your 3-3 notes pulled up, and we're going to be working with logarithms today. And sometimes when working with a logarithm, it's not entirely possible to change modes and turn it into something exponential. So in that case, I'm going to show you how to just kind of manipulate some logarithms. So I'm going to be showing you more properties. Now, on the top of your notes, I know there's a lot of properties up there. Don't worry, you know these already. You really do. The properties on the left just kind of remind you how to go from a logarithm to an exponential function. How to go, same thing. Same thing if you're only, that's log base 10, same thing log base e. So you know all that already. These are just the properties that I've already talked about, like 10 to the what is 1. You know this. How about e? E to the what is 1. You know these. 10 to the what is 10. So I've been over all those properties. Let's jump right into change of base. Back in the day, people needed to evaluate logarithms with a different base. So let's say that you're taking a test and you're only allowed to use your scientific calculator, and I don't think your scientific calculator can handle logs with weird bases. I'm pretty sure your scientific calculator can only do log base 10 or log base e. So what if I need you to get a decimal for like log base 7 of something? Well, then you have a dilemma. So there's this thing called change of base formula. And you can choose, using change of base, you can choose whether to use log base 10 to evaluate your logarithm with a weird base. You can choose to use log base 10, or you can choose to use log base e, which is the natural log. This is always my go-to. I prefer log base e. I use it more often than any other log out there, especially in calculus. So, but I'll show you both ways. Either way you go, log base 10 or natural log, you're going to take the log base 10 of this number divided by log base 10, same, of this number divided. Or you can do natural log of this number divided by natural log of this number. Either one will work. I'll show you how to do them both. So in the first problem, I'll show you how to do log base 10. So let's say the problem is saying, let's evaluate log base 3 of 7. This isn't something we can do in our head. I'll try real quick. Ready? 3 to the what is 7? I don't know. 3 to the first is 3. 3 to the second is 9. It's got to be 1 point something, but I don't know what it is. And my calculator, I don't believe, can handle it because it's log base 3. So to get it into a form where we can use our calculator, I'm going to go log base 10 of 7 divided by log base 10 of 3. I'm going to divide that out using my calculator, and I get approximately 1.7712. Might want to try that out real quick. Same type of problem. I need to evaluate log base 12 of 5. Well, I don't know what that is. Let's see. 12 to the what is 5? No idea. It's got to be less than 1, because 12 to the first is 12. So 12 to the what is 5? I have no idea. So I'm going to try this using change of base and natural logs. So I'm going to go, this goes on top. I'm going to go natural log of 5 divided by natural log of 12. And I get approximately 0.6477. So, change of base formula. Try them on your calculator. Whichever one you prefer, memorize it. Then we have, okay, now these do look intimidating, and they kind of are a little bit until you get the hang of them. They're intimidating until you get the hang of them. We can expand logarithms, and we can condense logarithms. So the first thing I'll talk about is expansion. So I'm going to talk about the whole left-hand column over here. So product law with expansion. Here's what the product law says. Let's say you have one logarithm, and what you're taking the log of is actually two things multiplied together. You've got one logarithm. What you're taking the log of doesn't matter what the base is. What you're taking the log of is two things or more multiplied together. You can expand that. You can expand this multiplication into separate logarithms using addition. So this one log with multiplication splits into two separate logarithms with addition separating them. So we get the log, same base of this piece, plus the log, same base of this piece. Expansion. We can expand multiplication using addition. All right, quotient expansion. What if you have one logarithm and you've got what you're taking the log of is two things being divided? You can expand this into two logarithms separated by subtraction. So log of this minus log of this. And lastly, the power law. This one's kind of cool. If what you're taking the log of has an exponent attached to it, there's a log out in front, exponent attached to it, you can take your exponent and transport it down to the front of your logarithm, and it becomes a constant times the logarithm. Let's say you're doing the log of b squared. You can move the 2 down in front, and it would become 2 times log of b. Now, these all also work backwards. So I called this expansion. I expanded this from 1 log to 2 logs. You see that the right side is more expanded than the left side. Expansion. Start with 1, expand it to 2. Well, you can also go backwards. The difference between expansion, the opposite of expansion is condensing. So, I've got 2 logarithms, same base, 2 logarithms. Let's say I wanted to condense those into 1 logarithm. Well, I've got 2 logarithms with addition. I can condense those using multiplication. So these 2 turn into 1 log, and this becomes 3 times 5. It's the property that I just showed you, backwards. Subtraction. Notice I have 2 logarithms. Look how long the problem is. I can condense these. I can condense them into 1 single logarithm. So I condense them into 1 logarithm, but since this is subtraction, this becomes 1 logarithm of 20 divided by 4. And then, you know that thing that I showed you about your exponent? Well, you can also put it back up. So I told you can carry it down. Also, if you've got a constant in front of a logarithm, you can take your constant and set it back up to the top. Put it back on as an exponent. That's totally legal. All right, so taking those properties, and let's just kind of go through them. It says we're going to do some rewrites. So the first thing I did is I recognized, hey, I've got 1 log and I've got division. So I separated it. I expanded it into 2 logarithms. And this was division, so I used subtraction. So 2 logarithms with subtraction. Natural log of 6, I have no idea what that is. Natural log of e squared. Well, look, the 2 here on my e can come down into the front. Natural log of 6, no idea. 2 times natural log of e. Ooh, this is a thing. This natural log of e, this is a thing that you should be able to figure out. Some of you know it, some of you don't. Let me show you how to figure it out. Ready? Pretend this equals question mark. E, forget the 2. Base is e. E to the what is e? That's just 1. So I've got natural log of 6 minus 2 times 1 is just that. All right, log base 9 of 27. The first thing I decided to do was I turned my 27 into 3 cubed. And then, what did I do? Then I brought my 3 down in the front. So this 3 up here, I brought it down to the front. And then, ooh, this is a thing. Log base 9 of 3. 9 to the what is 3? Well, I know that the square root of 9 is 3, so 9 to the 1/2 is 3, so I change this logarithm to 1/2, and I get 3 halves. Okay, more. Hey, let's figure out this logarithm. Yes, you could change it to exponent notation, or exponential function. Or you can use properties of logarithms. So since we're on properties of logarithms, that's today's notes. I'm going to use properties of logarithms. So I'm going to separate it. Right now it's division. I'll separate it into 2 using subtraction. Expanded it. You all can evaluate this one. 5 to the what is 1. And you all can evaluate this one. 5 to the what is 125. Okay, and I know, some of you might have been able to figure out the answer up here on its own. That's okay. Next one, I wrote the cube root as an exponent power. The cube root of 6 is 6 to the 1/3. That's something that you need to start recognizing kind of quickly. Square root, power of a half. Cube root, power of a third. Fourth root, power of a fourth, and so on. You can bring your exponent down to the front. So it's 1/3 times log base 6 of 6. This is a thing. You should be able to figure this out. Log base 6 of 6. 6 to the what is 6? That's 1. So you get 1/3 times 1. Last one, I brought my exponent down to the front. So I've got that times log base 3 of 81. Ooh, log base 3 of 81. This is something you can figure out. 3 to the what is 81? So this logarithm you can do 3, 9, 27, 81. The answer to this log is 4. So my answer to the problem is -0.8. Okay, these two on the back are interesting. I started them 2 separate ways. So let me kind of start with part B real quick. For part B, what I'd like you to recognize is, yeah, we're doing a common log of all this. And notice this entire fraction is being square rooted. So what I did is I wrote my entire fraction to the 1/2 power. Now, to finish out this problem, it is totally legal to take this 1/2 power on here and put it in front of the logarithm. Like that. However, let me stop there. Let's go back to this one. It is not legal at all yet to take this 3 and put it in front, or take this 2 and put it in front. Because neither the 3 nor the 2 go on everything that I'm taking the natural log of. Like the 3 is only attached to the x. It has nothing to do with this y squared. You can't put it in front of the whole problem if it doesn't have anything to do with the whole problem. So what you have to do first is separate them. Keep this on, separate, expand with addition. Okay? So I did ln x cubed plus, expanded with addition, ln y squared. I expanded them. Now the 3 can be moved to the front of that log, and the 2 can be moved in the front of that log. This 3 has nothing to do with the 2 or the ln or the y over here. That's why neither of these could have been moved down at the very beginning. All right, let's go back to number 2. So I kind of showed you one way to start on this. Let me show you another way. This way turns out to be actually quite a bit easier. What I did here is I took kind of went back to Algebra 1. And remember in Algebra 1 when you were raising powers to a power? Well, here the rule is you multiply your exponents. So if I multiply this exponent times this, I get x to the first. And if I multiply this exponent times this exponent, I get y to the 3 halves. And then 1 log division, I expanded them. And I moved my 3 halves down to the front. And that's my final answer. And I could have gotten there had I carried on the other way, which I kind of started earlier. But there were more steps involved, and I just liked this way better. All right. We're getting close to the end. We're supposed to condense to a single logarithm. So I've got this highlighted. We're supposed to write it as a single logarithm. That means 1 log. That means at the end, I can only write log once. Or I can only write ln once. 1 logarithm. Here we go. I'm condensing, okay? So I move the 2 back up on top of the a, and I move the 3 up on top of all of this. The whole thing. Not just the b squared, but the 3 goes with everything. So notice how I wrote that. Move the 2 up. The 3 goes with everything. So I put the 3 with everything. And then I condensed it. So when I condense it, I've got addition. I'm going to condense it to 1 logarithm multiplication. 1 logarithm, this times this. And then I just kind of rearranged and simplified a little bit, and that's what I got. Just rearranged and simplified a little bit. 1 logarithm. Moving on. I'm going to condense, okay? I can condense 2 separate logarithms with subtraction. I can condense it using division. First of all, do not distribute ln. This is not ln times the quantity. This is ln. This is the log of all this. So can't do anything with this. But I am going to condense them into 1 logarithm. 1 logarithm. So I'm going to use 1 logarithm, and it becomes this piece over this piece. And then I was like, oh wait, look, they all have an x on them. Every single one of my terms has an x on them. So still one logarithm. I decided to factor out an x from here, and then these x's can cancel. And that's my final answer. Part C, the first thing I did was I cleared the parentheses, so I distributed my 2. Yes, you may distribute a 2. You may not distribute an ln, but you may distribute a 2 times. Put your 2 in. So, same, distributed the 2, and then I moved all my coefficients up. So I moved this coefficient up here, and it became an exponent. I moved the 2 up here, and it was like, oh wait, there's already 3 there. Yes, there is. Multiply. And then I moved the 8 up. Kept that a minus, moved the 8 up. 3 logarithms. 1, 2, 3. These 2 can condense with multiplication, and this one's going to be division. 1 logarithm. That's how they condense. Those 2 here with multiplication, this one underneath with division, and then I separated. X to the 10th over x to the 8th is x squared. Last one, we're trying to condense into single logarithm. So, of course, I moved the 1/2 up here as an exponent. And then for this one over here, this is going to seem totally weird. Try getting this to match this. So how can you write 1 as log base 5 of something? Log base 5 of 5 is 1, right? 5 to the what? So, weird as it seems, I changed the 1 to this. And I kept the second one the same, and now I can condense to 1 logarithm using multiplication. You may write it like this, or knowing what the power of a half means, you may write it like this.